When I get to example 3, really, I just have two multiplications taking place. And then I'm going to subtract the results. Well, because I have this negative here, I know that whatever I get when I multiply out the x plus 2 times x plus 8, I'm going to have to flip the signs afterwards. So to make it easier on myself, I'm going to put brackets around whatever the result of these multiplications is. So for the first one, I can see that it's the same two terms, but one is positive and one is negative. So I know the result from that is going to be x squared minus 25. First one squared minus the second one squared. Don't forget the minus here, and then I can expand this out. And I'm going to say that for the second part, it's going to be x squared plus 8x plus 2x plus 16. Well, this is just going to be x squared minus 25, because it doesn't have a coefficient on the outside here, minus x squared plus 10x plus 16. And I know that the negative here, like we had said at the beginning, is going to flip all the signs of the x squared, the 10x, and the 16. So what I have is x squared minus 25 minus x squared minus 10x and minus 16. When I combine the like terms, positive x squared and negative x squared will cancel each other out, and I can combine the negative 25 and the negative 16. The negative 10x does not have a like term. So my final result is going to be negative 10x minus 41. For B, I need to take the same idea into account. It's still going to have that negative there. I also need to be careful because for this one, it's not the same values. One has 9a, but the other has 4a. So it's not the same as when we did that special multiplication where I get a difference of squares. It should not be a difference of squares answer here. So I'm going to multiply out the two sides and then leave brackets for whatever the results are, so then I can apply the negatives or whatever I need to apply once I get to that step. So when I expand this out, I get 36a squared minus 81a plus 16a's minus 36. And I'm subtracting from that 36a squareds. The 6a times negative 5 times 2 gives me negative 60a and plus 25. I'm going to combine the like terms here, and what I get is the 36a squareds minus 65a's minus 36, and apply the negative from here into the second set, and I get negative 36a squareds, positive 60a's, and negative 25. The positive 36a squared and the negative 36a squared are going to cancel each other out. The negative 65a, and the positive 60a leaves me with negative 5a's, and the negative 36 and negative 25 gives me negative 61. For example 4, same idea, just slightly more complicated multiplications. So I can see that for the first set, I have a term that I need to multiply into all three parts here. For the second set, I need to expand out the set and then apply the negative. So what I'm going to get when I multiply the 5x into the first part is 15x to the power of 3 minus 35x squared plus 5x. I'm subtracting from this when I expand out the right-hand side 20x squared minus 32x plus 15x cubed and minus 24x squared. Well, I could apply the negative right now and then just combine my like terms if I don't care about combining these two terms in here, and say that I have 15x to the power of 3 minus 35x squareds plus 5x minus 20x squareds plus 32x's minus 15x cubed and plus 24x squareds. And then I'm looking for the like terms. I have a x to the power of 3, I have an x to the power of 3. And these two are obviously going to cancel each other out. I have x squared, and x squared. And those are going to combine to give me negative 31x squareds. And last but not least, I have my x's, which will combine to give me positive 37x. For the second set, I'm going to multiply out my complex multiplications, leave it in brackets, and then apply these coefficients. So I'm going to start with 4, and when I multiply out this set, I get 6x squared plus 4x minus 21x minus 14, and this is going to be minus 8, and I'm going to get 3x squareds minus x minus 3x and plus 1. When I expand this out, I get 24x squareds plus 16x's minus 84x's minus 56 minus 24x squareds plus 8x's plus 24x's minus 8. And then it's a matter of doing the same process. I have my x squared, I have my x squared, I have my x's, and I have my constants. I combine the like terms. The x squareds will cancel each other out. And then I'm just left with negative 36x's and negative 64. For the last example, given that for every value of x, the polynomial x squared plus 20x plus 50 can be written in the form of x plus a squared plus b, what are the values of a and b? Well, if this is true, and I expand this out, then x plus a squared is going to give me x squared plus 2ax plus a squared. And I still have that plus b at the end. This is equal to x squared plus 20x plus 50. And I can see here that my x squared here is still my x squared. I can see that the term with the x is right here. And the trickier one to understand is that the a squared plus b will combine together to make whatever that 50 is. Well, I'm going to start with the middle. I'm going to start with, if I know that 2ax has to equal 20x, I could divide both sides by x and cancel those x out, which means that 2a is equal to 20. If I divide both sides by 2, then a is equal to 10. Now I can solve for b. If I know that a squared plus b is equal to 50, well then that means that 10 squared plus b is equal to 50, or 100 plus b is equal to 50. I'm just going to subtract 100 from both sides and get b is equal to negative 50. And there's my solutions. All right, go ahead, get some practice done.